In our last video, we had a look at the different types of equations that you get. Linear equations, where x is to the power of 1. Quadratic equations, where x is squared. Exponential equations, where the unknown is in your exponent. Surd equations, where you need to square both sides to get rid of a square root, or cube both sides to get rid of a cube root. And simultaneous equations, where we solve simultaneously for more than one variable. What we're going to do today is focus on these quadratic equations. In our last video, we focused on ones that can factorize. So, for example, if you were dealing with x squared plus 3x plus 2 equals 0, this is a trinomial here that can factorize, and then you can solve, and you can end up with two answers. But what we're going to look at today is being able to solve quadratic equations that don't factorize. So when you get a question and you're not sure how to solve it because you cannot see a common factor or a trinomial. So if we look at this example here, x squared plus 7x plus 2 is equal to 0. What we would normally try and do is we'd get the factors of 2 and then try to use them to create this middle term of 7. But in this case, you'll start to notice it's not possible. And so when we have that, we've got two options. Our first option is completing the square, and our second option is actually derived from completing the square, and that is the quadratic formula. Now, generally, we will encounter at least one question in our exam that requires us to complete the square. So I found a lot of grade 11 students really enjoy this quadratic formula method, and that's fantastic, but it's very important that you know how to complete the square, because if the question specifically states that we need to complete the square, then we are not allowed to use any other method. We need to complete the square. So let's have a look at how that works. The question says solve for the unknown by completing the square. So in this equation here, x is the unknown, and they have specifically said completing the square. So we don't have any other options. If they didn't say that, we would have looked at the 2 and said, how can I use the factors of 2 to create this middle term? And we would have come to the same conclusion. It doesn't work. Okay, but they've specifically said here, completing the square. And so that is something we are going to do. When asked to complete the square, the first thing we need to check is this in standard form? So in other words, are we working with x squared plus 4x plus 2? In other words, descending powers of x. And we are. The next thing we want to do is move the constant term to the other side. So we want to get all terms with x on the left-hand side, x squared plus 4x, and we want to move that constant, positive 2, to the other side where it's going to be negative 2. Now they've asked us to divide by a where necessary. So a is the coefficient of the x squared term, and in this question, we are simply looking at the number 1. So it's not necessary for us to divide everything by 1 because it will remain unchanged. But if this is anything other than 1, even if it's negative 1, we would need to divide every term in the equation so that we end up with the coefficient of x squared being a positive 1. Next, we need to add a half b squared. Okay, so in a trinomial, we always look at the coefficient of the x squared term, that's our a value. The coefficient of the x term is the b value, and the constant is the c value. So just to make sure that we know what we're talking about. So there was our a value, our b value is what we're going to deal with now, and our c value is what we moved there in the second step. Okay, so they want us to add half b squared. Okay, let's have a look at this. B is currently a positive 4. Half of 4 is 2, and we're going to square that. 2 times 2 is 4. Okay, and what we do to one side, we do to the other side. So that's just a rule of equations. And we are finally ready to factorize and solve. Okay, why have we done this? Well, let's take a look. What you'll notice is that on this side now, we have created a perfect square trinomial. So the whole point of completing the square is working towards having a square bracket on the one side. So what does that look like? Well, let's see. Factors of 4 are 2 times 2. And I can use a 2 times 2 to make that middle term there of 4. So x plus 2 x plus 2 will give me, if I were to FOIL and multiply this out, it would give me that term there. So x squared plus 2x, and then plus 4. So this left-hand side has now become a perfect square. So x plus 2 squared is equal to, and then on the right-hand side, minus 2 plus 4 is 2. Okay, and I want this to be the case because I couldn't factorize this into a beautiful little trinomial with 2 neat brackets. So what I want to do is I want to get a square on this side, because then I can use the opposite of a square, which is a square root. So I can square root, and whenever I introduce a root, I do it with a plus or a minus. So what I do to the one side, I do to the other side. I'm going to square root that x plus 2 brackets, and the square and the square root will cancel each other out, which is perfect. And then on the other side, I am left with plus or minus the root of 2. Now to solve this, I'll simply move this 2 across, and so I'll end up with x on the left is equal to minus 2 plus or minus the root of 2. Okay, and then it's about reading the question. Okay, the question will either say, give your answer in surd form, or give your answer to 2 decimal places, or however many decimal places. And where they don't specify, we need to go back to the cover page of whatever test or assignment we're working on, and there, most of the time, they say 2 decimal places. So that's what we're going to do now. We're going to say, well, either x is equal to minus 2 plus the root of 2, or x is equal to minus 2 minus the root of 2. And we're going to get those answers to 2 decimal places. And there we have it. Either x is equal to minus 0,59 or x is equal to minus 3,41. So what we've done is we've taken a trinomial that cannot be factorized, and we have still managed to solve the quadratic equation by completing the square. Let's look at another example, and we've got our steps here along the side so we can just keep ourselves on track. Okay, step 1, is this in the standard form? Okay, so standard form would be descending powers of x. So that's the first thing I need to change. I need to rewrite this as 3x squared plus 6x minus 2 equals 0. Okay, that's my first thing. The reason we need to do that is because it helps us to identify that we've got an a value, a b value, and a c value that we'll move there when we deal with the constant term. Okay, so if it's not in standard form, things get complex. Alright, so step 1, standard form, we have done that step. Step 2, move the constant term across. So 3x squared can stay, plus 6x can stay. That minus 2 moves over and it becomes a positive 2. Then we are asked to divide by a where necessary. So now the a value is not a positive 1, which means we have to divide everything by a, because what we want is 1x squared as our first term. So x squared there, plus 6 divided by 3 is 2x, is equal to 2 over 3. That doesn't divide nicely, so we're going to leave it as a common fraction for now. Then we need to add a half b squared to both sides. Okay, so now at this point, we're going to reassess, and we're going to say, what is the b value currently? So we are currently looking at a 2, okay? Then we want to add a half of that, so half of 2 is 1, and we want to square it. 1 times 1 is 1. What I do to the one side, I do to the other side. So now we're ending up with what should be a perfect square trinomial, because we're at this step now, factorize and solve. So in other words, I should be able to write this as x and something squared is equal to, let's quickly work that out, 1 2/3 on that side. Okay, so let's figure out how this would factorize. Okay, factors of 1, 1 times 1, and how can I use them to make a positive 2, that middle term? So that's just going to be x plus 1. Okay, a nice easy trick here is you can literally just take half of the b value and you will figure out what that last term is in the square bracket. Alright, the whole reason we wanted that was because that means we can square root both sides. Remember, when you introduce a root, you introduce it with a plus or a minus. Okay, why do we like to do this? Because this root and that square cancel each other out. So we've now got x plus 1 is equal to plus or minus the root of 1 and 2 over 3. Let's take that plus 1 over, so x is equal to minus 1 plus or minus the root of 1 and 2/3. And then we're going to work that out on our calculator and give our answer to 2 decimal places. Okay, be very careful when you type this in to your calculator, because a lot of students don't know how to type in a mixed fraction. Okay, you can't write 1 and then straight next to it write 2 over 3. You actually need to use the shift button and then your fraction button. Otherwise, what's going to happen is you are going to end up with a multiplication thing. Okay, so just be careful there when adding an improper fraction. Make sure you're using a notation your calculator understands. So there we have it. X is equal to 0,29 or minus 2,29. Now let's take a look at the quadratic formula. So we've become familiar with this general term here in the standard form, ax squared plus bx plus c. So the coefficient of the x squared is a, the coefficient of the x is b, and the constant term is known as c. And if you complete the square on this, which we don't have time to do today, but if you do it, you can go try it, you come up with what is now known as the quadratic formula. So if ever you have a quadratic equation, in other words, x is squared, and you cannot factorize it, you can use this formula and you can solve for x or whatever the variable is that is unknown in your equation. And you can do so by saying minus b, you substitute in your b value, plus or minus the square root of b squared minus 4ac. And then you divide that all by 2 times a. Let's have a look at this formula in practice. So here we've got 2 questions, and this one specifically says give answers to 2 decimal places. So that's a big clue for us that we are going to use the quadratic formula. Okay, they haven't specified that we need to complete the square. So we would be allowed to if that's our choice. But in this case, we are going to use that quadratic formula and put it to the test. Okay, so the first thing I do is I check what's the a value, what's the b value, and what's the c value. Okay, a is now 3. B is a positive 1. Okay, it's not written there, but I know it's 1 when there's nothing written. And C is minus 4. Okay, so I can go straight over. These formulae are usually on our formula sheet. So A is equal to minus B plus or minus the square root of B squared minus 4AC all divided by 2A. Okay, don't get confused because we're solving for A and there are A's in this formula. We need to be alert. Okay, so A is equal to, all right, we saw that the B value there was positive 1. So we're going to have a minus, and then we're going to substitute in our positive 1, plus or minus the square root of, again, we've got B squared minus 4. The A value there is 3. The C value there is minus 4. And all of that needs to divide by 2 times A, which we now know is 3. Okay, now you can, if you're comfortable, you can straight away go to the step that says, okay, well, minus 1 plus this root divided by that. You can jump to that. I like to just neaten it up a little bit and work out what's under my root and work out what the denominator is. Okay, and I do that either in my head or on my calculator, whatever. You can do whatever you're more comfortable with. So there we have it. I've worked out this little bit under the root. That's 49. And I've worked out that 2 times 3 is equal to 6. And so now I can jump straight into the step where I'm going to get my answer. Either A is equal to minus 1 plus the root of 49, which is actually a perfect square, so we're going to be able to work that out nicely. Or A is equal to minus 1 minus the root of 49, all divided by 6. Okay, so minus 1 plus 7 over 6, or minus 1 minus 7 over 6. Okay, and they want 2 decimal places. So I'm going to work it out, and I'm going to say minus 1 plus 7 over 6 is equal to 1. Or in this case here, I've got decimals. Minus 1 minus 7 divided by 6 gives me 1,33. Okay, so that was our first example. Let's have a look at this example 2. 9 bracket x squared minus 1 equal to 7x. Okay, the first thing we want is standard form, so we can figure out our a, b, and c values. So let's multiply that 9 in there. We're going to end up with 9x squared minus 9. Let's also, while we're at it, bring this 7x over, because we can't factorize until we've got 0 on the one side. So that's going to be minus 7x equals 0. And now we can write in standard form 9x squared minus 7x minus 9 equals 0. And I'm now ready to have a look at a, b, and c values. Okay, so the a is 9, b is minus 7, and c is minus 9. Let's work that out. So in this case, the unknown is x. So x is equal to, and we can put down our formula, minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. And now we can substitute. So minus, the b value is minus 7, plus or minus the square root of b squared minus 4ac, all divided by 2 times a. And now let's just neaten that up a bit. So we work out this bit under the root and we work out our denominator, and then we can jump straight to our answers. The one where we're going to take the addition, so that's 1,46, or the other option where we take the subtraction, so 7 minus that root, all divided by 18, and that gives us minus 0,68. So there we have it, quadratic formula, nice and simple. If you check with your teacher, will you be getting this on a formula sheet, or do you need to memorize it? And then make sure that your equations are always in the standard form before you substitute into the formula.